Hi, everybody. Thanks for coming. My name is Trent Peterson, and I'm a product manager for AWS Device Farm. And today, I'm going to talk to you real quick about what Device Farm is, in case you're new to the service or you've not tried it yet, and what we've done since we launched in July. We've changed a few things, introduced some new functionality. So I'll cover that really quick, and then I'm going to have engineers from IHS and Etsy come and talk to you about how they're addressing quality in their mobile applications through tools like Device Farm, as well as other systems, and how their processes look and what lessons they've learned. And hopefully you can take some of their lessons and some of the things that they're doing and apply them to your own development process. So Device Farm launched in July. We launched with Android support, and then a few weeks later, we introduced iOS support. So you can test on hundreds of real iPhones, Samsung devices, Kindles, and so on. These are actual physical devices that we house in AWS data centers. So rather than you having a closet full of devices, we'll be your closet of devices. You can run your tests on AWS in the cloud. The devices themselves are non-rooted, non-jailbroken. They're OEM and carrier branded. We have different operating systems. There are hundreds of different OS and hardware combinations available for you to test, and we're constantly adding more. We just added, over the past few weeks, the Galaxy S6 and the iPhone 6s and 6s Plus, iOS 9, Marshmallow is on later today. So it's also designed with security in mind. So the devices themselves are both hardware and software isolated. So when you're running your test, you can't see another device next to you. So that it was designed with that in mind. I also mentioned that we have hundreds of different SKUs available. We also have multiple instances of each so that we can make sure that when you want to run your test on a specific device or set of devices, that those devices are available to you for your testing. It's also flexible. So it was designed not to dictate to you which test framework you should use. And there are many frameworks out there, and there are many reasons to choose a specific framework. It might be your team's skill set, what you're good at. It could be that it's a specific type of test or the type of application you have demands a specific framework. So we support a number of frameworks. So everything from JUnit and XC test, the official Google and Apple frameworks. We also support things like Calabash and Appium and Robotium and various frameworks that allow you to use the framework of your choice. When you run your tests, the most important thing is the results, right? What happens after the tests have run. And so we take care of pulling in all of the screenshots, all of the results, logs from the devices. We pull them all in for you into an aggregate report, and you can use this report from the console itself, so you can navigate to a specific device, a specific test, or see a high-level view of how your app's performing across a given set of devices. You can also grab this through our API and SDKs. We also have plugins for things like Jenkins. You can also integrate with Android Studio. So it really, you can use it through the console, like I said, and you can also use it during your development cycle and your QA cycles and kick things off automatically. And then lastly, in typical AWS fashion, you pay for what you use, right? There's no upfront cost. There's no flat fee. It's just pay as you go. So it's affordable. So with that, now that I've talked about Device Farm a little bit and kind of introed it, I'm going to let some folks from IHS and Etsy talk to you about how they use Device Farm and, like I said, other tools and what their processes look like. So first, I'm going to welcome Sean Castriani from IHS to the stage.
Thank you. Hello, my name is Sean Castriani. I work for IHS Global. For those that don't know what IHS is, if you've ever watched C-SPAN, you may see an IHS financial analyst on there talking about various things. We're the leading global provider of information and analytics for oil and gas, as well as military, chemicals, energy, financials, we're also getting into risk management, which I will talk about a little bit later. We employ over 8,000 employees over 32 countries, and because of all the information we have, and because we have all these different types of information, what you can kind of combine together, to do various analytics that you couldn't do if you just had one type of information alone. A lot of governments and other businesses will usually be our customers. So of all the different areas that we're in, we have a few mobile apps in all those different areas. I actually work for I'm the principal mobile architect of the Energy Technical Division of IHS, and we have an app for that. But the app I'm going to talk about today is called First Report. This comes from our risk management division. So imagine a large enterprise that runs some kind of warehouse, maybe with lots of heavy objects on high shelves and heavy equipment that move around. People might get injured there. So you want to make sure that if anything does happen, or maybe something almost happens called a near miss, you want to be able to record that information to try to prevent it from happening again. So this particular app called First Report, the name is a good name because you want to be the first one to report what happened. You want to be able to take pictures of the incident, maybe record your voice and type in information, submit that to some server so that something can be done about it next time. This particular app has Android and iOS. It also, just like any other data capture app, you want to have an offline usage for it because you don't want to not be able to take a report if you don't have an internet connection. So this supports offline usage. And obviously, in order to take pictures, it does integrate with the camera. So why would you want to automate your mobile testing? Well, if for those that have tried just doing manual testing, you'll easily find out that just a few people doing manual testing cannot handle all the different device types and different operating systems and all the different scenarios that you need to test. And then as your company creates more and more mobile apps, you have different versions of those and patching those. There's just so much things you have to test. So you're going to automate those because you may have limited QA resources. My particular team for this app just has one QA resource. And obviously that's not enough to handle all these different devices. So also another would be regression testing. As you make these new versions and you fix bugs, you want to make sure you don't break anything that was there before, or that you fixed before. So you want to have all these suite of automated UI tests that you can run, so every time you check in, you'll know that everything still works. So that's regression testing. And then for those manual tests that you do have, it's very possible that the QA person could make a mistake while you're going through the test plan. You may skip a step or something unexpected happens. You want to avoid those manual mistakes. So having an automated UI test suite will give you more repeatable results. Then a big one that actually these last two things really affected us hard, which is where AWS Device Farm came in and helped out, is Android, and specifically, Google makes a lot of changes to the Android operating system. And in particular, there's one case where they made a security fix, where when one activity, if you're an Android developer, you'll know what an activity is. When one activity was talking to another activity, they increased the security between that communication between the two activities. And by increasing the security, it broke our app. So we had to go back in and add some extra code to make it backwards compatible. So that'll work with the new secure way as well as the way that was before they made that change. So you may have to add code to be backwards compatible. So having the ability to test on all these different operating system versions will be able to catch these types of things. And the last one is differences in physical hardware. So my product manager, for example, has an older Android device which had less memory than the one that I was testing on. So he would say that something didn't work, and I made the classic statement that all developers make, that it works on my device or it works on my machine. Well, it turned out it was because of his device had less memory than mine. So again, having a whole device farm of all these different devices with different hardware capabilities would also catch that. And it's most important for Android because they have over 7,000 different devices running Android 4 or higher. And most people seem to target Android 4 or higher to get the most market share. Okay, so I'm going to go through a little bit of our overall high-level development testing process, and I'm going to talk in detail about each block so you can see what technology we used at each step and why we chose it. So let's start with developing. I'll skip all the requirements gathering, all that stuff, for now. We'll just talk about development and testing. So for developing, So our company is mainly a .NET shop. So we have lots of C# developers, lots of Visual Studio users. So it made a lot of sense to choose Xamarin as our development tool. Xamarin allows you to use C# when you write your code for Android and iOS. And if you do use Windows Phone, that's natively C#. So you can use C# on all 3 mobile platforms. Therefore, you can reuse a lot more code. And also, they provide the ability to write this code in Visual Studio. So again, all of our Visual Studio developers already had, it was an easy win for us. What Xamarin basically provides is a C# wrapper around the underlying SDK. So whatever the iOS SDK can do or whatever the Android SDK can do, you can do it in C#. It's a one-to-one mapping. So you get the full power of the underlying platform. And then if you can code your application or architect your application correctly, you can get about 65% code reuse, and that's kind of being conservative. You can get way more than that. So if you think about from a quality perspective, the more code that you can reuse, the less you have to test more than once. If you test the shareable code, it's tested for both platforms. Okay, so that's our development. Let's skip around a little bit. I'm going to leave the automated build for last because that kind of integrates everything together. So I'm going to talk about that one last. So let's go to the beta deployment. So if you are going to do manual testing, which you should do that as well, and also you want your product managers and other outside external beta testers to test your app, you're going to have to deploy your app before it's ready to release. So for beta deployment, we use 2 things. Hockey app was purchased by Microsoft, and it allows you to beta deploy almost anything. They definitely support Android and iOS out of the box. We can also deploy a Mac desktop software or Windows desktop software, but of course we just mainly use it for Android and iOS. Now one thing that's important to note on Hockey app is when you're deploying with an iOS beta app, you have to use a development provisioning profile. And for those that know iOS development, you know what I'm talking about. But that basically means the app that you create is only good for beta deployment. You could not put that on the App Store for general consumption. So whatever you're beta deploying won't be the same binary that you're going to later deploy to the App Store. And that could be an issue. You want to try to have the app that you test be the same app that you ship. So TestFlight, Apple comes in, they bought TestFlight, and they solved that problem. So with TestFlight, if you distribute via your beta versions through TestFlight, you can use the same exact binary with the distribution provisioning profile, the one that's good for the App Store on TestFlight. So again, that's very important. When QA hears that you're shipping the same binary that they tested and that the automated tests were run against, that's good news to them. Okay, let's move to the automated UI test. And now I've got simulators here. The Device Farm we'll hit in a little bit later. So for simulators, in this flow here, we can see that after we've developed and we've committed that to a source code management system, and that triggers an automated build. I put the word always in here. On every single automated build, we're always running these automated UI tests, but on the simulators. Because we decided that if a developer is going to make a spelling change or add a comment to a source line of code, there's really no reason to fire up Device Farm and all those physical devices because there's really no real change there. But it's it doesn't cost anything to run on the simulators, of course. So we run the simulators all the time on the build machine. Our particular build machine is a Macintosh system because you need a Mac to build iOS, but Macs can also build Android devices, apps. So on one build machine, a Mac, we can build both Android and iOS, and both simulators are running on that Macintosh hardware, so it can fire up the automated UI test on both platforms. So how did we write these UI tests? Well, as Trent mentioned, Device Farm supports many different, is very flexible, so that you can write these tests that Device Farm will support in Appium or UI Automator and Calabash and et cetera. We actually chose Appium, and with Appium, it's also flexible in that you can write your Appium test in any different language. It's basically just a REST web service, if you will. So as long as your language can speak REST, you can use Appium. So the languages, out of the box are Ruby, Python, Java, JavaScript, C#. Currently, the Amazon Device Farm doesn't support Appium test written in C#, but that's coming. In the meantime, we're using Java because Java and C# is almost identical. So our C# developers can just as easily write code in Java. It's pretty much the same thing. So we're writing our tests in Appium with Java. And then what you actually run those tests with, because the tests were written in Java, we're using JUnit to run those tests. And then what's nice about Appium is the bullet in bold there says no special build is required. So unlike Calabash, for example, when you compile your app to be tested in Calabash, you need to inject the Calabash server inside your app, for iOS anyway. So therefore, this app is special. It's special in that it's got something in it solely for testing purposes. It would be better to be able to test your app as if it would, the version that would be on the App Store, and Appium allows you to do that. So no special builds required. And then in terms of writing the tests, if these tests are Java or C#, you might think it's a development responsibility to write these tests, and definitely developers can write them. But you also want QA involved in writing these automated tests, but QA may not have a development background. So with whatever language you pick for Appium, there's probably going to be some kind of behavior-driven development way of writing those tests. So Java, for example, there's something called JBehave. And behavior-driven development, I just think of as a way to code in plain English. So that would allow a QA person that doesn't have a development background to write their test in plain English using JBehave, for example, which then is really just Java, which then is just using Appium, which is just really a REST web service, which is talking to the app. Okay, I'll move on to the next one. The other big thing for Appium is they have something called an Appium Inspector. This is also very nice for people that don't have a development background, and plus if you aren't familiar with the app, is on this Appium Inspector you have a screenshot of what the device or simulator has. You can see that on the right. And then on the left is the UI control hierarchy. So as you click things on this screenshot, it actually shows you the hierarchy and how to identify that UI control so that you can then reference it in your test. And then on top of that is, if you actually hit the record button, then as you're doing this, you can actually remote control your app and be recording at the same time, and it's basically writing the test code for you. And it's hard to see, but you can also pick what language you want to write the code in. So if you're using Appium with Java, it'll generate Java code. Appium with C#, it'll generate C# code. So that's also very, very nice, especially if you don't have a developer background. Okay, let's go to Device Farm. So actually, let me go back. So back on the workflow here, we have automated UI test. We're running that all the time on every single build. After the automated UI test on the simulators is complete, then we have a manual step where we ask ourselves, is the code that we just built, is that some kind of a milestone build? Does it have enough functionality that it would be useful to be tested by someone? Obviously, if you just make a comment change or fix a spelling mistake, that's probably not a milestone build. But if it is, then this is when we do either our beta deployment for our manual testers as well as for product managers so that he can get their hands on it. But at the same time, we trigger an AWS Device Farm build in the cloud because we've integrated Device Farm with our automated build system using either the command line interface or their SDK. So if it's a milestone build, you click a button on the automated build dashboard. It gathers the app that was built. It gathers all the UI tests that you wrote, sends them up to Device Farm, and starts a run of all those tests on all the devices that you choose to test on. So why did we pick AWS Device Farm for our warehouse of physical devices? Well, as Trent kind of mentioned before, that they have hundreds of mobile devices. You don't want to have to buy all these different devices in-house. That's a lot of money, and it's a lot of devices that you have to keep track of. So it's just a lot easier to rent them from something like the AWS Device Farm. And plus, they have many different versions, platforms, OS versions, and instances, as Trent mentioned, so that you're not waiting on a device to become available. And then they have two different types of tests that you can create. One is fuzz testing, which is just almost like a monkey just clicking and typing and just trying everything out that it can find on your screen. That's if you don't want to write the test yourself. But you can, of course, you can also write the handwritten test like Appium, as I just discussed. And then, as I mentioned, you can use the AWS SDK or the command line interface to integrate it with anything, with the build system, for example. And then, also, as Trent mentioned, we chose it because it has the pay-as-you-go feature. Some other platforms will have flat fees. Well, we're still kind of starting out with experimenting with automated UI testing, so we want to have a pay-as-you-go so that we're not, to keep our costs down, basically. Okay, let's finish up on the automated build. So a lot of people probably have heard of Jenkins. We actually use something called Quick Build. It's very similar to Jenkins, so you can just think of it as being the same thing. It's Java-based because we want it to be cross-platform, so a Quick Build machine the server component can run on any type of device, and then it can have a whole grid or suite of build nodes that it can delegate to. And all those can be on any different type of platform, again, because it's Java-based. So we use that for our automated builds for Android and iOS. Again, as I mentioned, we run this on a Mac build server to do both builds. I mentioned that we do our beta deployment with Hockey App and TestFlight, and we use this Quick Build to integrate with those. We execute our Appium UI tests, as I mentioned, on the simulators, and then any milestone build we send up to AWS Device Farm. There you go. Thank you.
Thanks a lot, Sean. Okay, so we heard from Sean about how they're doing testing at IHS. And one thing that I'd like to point out is the difference in industries that we're talking about today. So we're about to hear from an engineer from Etsy. And what we've been hearing from developers since we launched is that regardless of the type of application, regardless of the size of the team or the type of company that they're in, that testing and ensuring the quality of their mobile applications is an increasingly important thing. That quality is increasingly important. Developers, struggle with it. It's very complex. And meanwhile, we as consumers of applications are very fickle, right? We don't like it when the app works on our phone, but then doesn't work on the tablet, or it crashes, right? So, we're really impatient with it. And so the importance of quality, is growing while it's also growing in complexity. I mean, more and more devices coming into the market. So it's interesting to hear folks from different types of companies talk about how they're addressing the same problem, different tools, different workflows, but the same problem, right? And they're addressing the same issues. So now I'm going to welcome Nassim from Etsy, who's going to talk to you about how they address mobile quality at Etsy.
Hello. So I'm Nassim. I'm a software engineer with Etsy, and I work on the continuous integration platform. I mostly focus on the mobile aspect of it, so both for iOS and Android. So Etsy, hopefully you've heard of it. We are an online marketplace. We put buyers and sellers together for everything handmade and vintage. We have about 1.5 million active sellers and about 21 million active buyers. 60% of our visits come from mobile devices, so they can be mobile web or the apps. And to date, we've had about 28 million app downloads so far. And so we have 4 apps, 2 iOS apps, 2 Android, 1 buyer and 1 seller on each platform. And we do not have any dedicated mobile app team. Every engineer on every feature team can contribute to the apps. Which brings us to, in average, 60 contributors on each platform. We try to release every other week, and occasionally we have bug fix releases in cycle. We have 2 release managers and a total QA staff of 8 people to cover the web, the mobile web, and the apps. So now I'm going to talk about our development processes a bit. On the web stack, we practice continuous delivery pretty heavily. So we deploy our site in average 50 times a day. Usually it's more like 70, 80 times. And so we try to mimic this philosophy on the apps. The whole idea is we want to detect issues as soon as they're introduced. And so we are experimenting with it still, but we have this concept of push queue. And the whole idea is you want to push your code upstream. So we use GitHub and Git. You want to push to master. You're going to join a channel in IRC. People who want to push at the same time are going to sync up with you this way. You push your code, and we run our battery of tests with all the builds that we have, all the linters and everything. And we're going to generate an installable app that the developer then installs on his device and tests manually. Make sure his code changes are fine, are great, and acknowledges it in IRC, and then we move on to the next train. We call those push trains. So the other idea is every time we push, we generate an installable build, and we test it on devices. If there is an issue, we catch it right away. And that's the old philosophy behind CI anyway. Catch the issues as soon as they are introduced. The screenshot that you see on the right is the landing page to download the enterprise app. So like Sean described, we have an enterprise program on iOS. It's easier on Android, but you have an enterprise program. And from that page, employees can go download the apps from master, from the release branch, the bug fix branch, or from the ad hoc branch. And the whole idea is, I'm working on a branch, I want to build, and I want to share it with my product manager, or with my employees, or my colleagues, rather. I can go to Jenkins, request a build, and that's going to generate an installable app. I can share the link. Anyone can, in the company can go and install it for my own branch. So that's pretty handy tools to have around. All the builds here are stored on S3, and it's just like a landing page, pretty much, to download those links. So before pushing upstream, we usually do code reviews. Like I said, we use GitHub. So a pull review is simply a review is simply a pull request, and we have a little script called review that we invoke. But the cool thing about it is every time someone push to a pull request, we kick off a build on Jenkins again and run all the test jobs and the build jobs, and then report back onto the pull request so that the reviewer can directly see, are we good to go or not good to go. So that's pretty handy. Sometimes for tiny changes, we don't want to put a pull request or a review. So we have another tool that we call try. So it's an open source tool. It's pretty easy. It generates a diff of your local changes against origin master. So it's simply running git diff origin master and sending that into a file. Then we send the file to Jenkins. Jenkins takes that file, that patch file, applies it onto the builder, onto the nodes, and then run the tests, run the linting, run the builds. So pretty much it's a way to test your local changes onto the CI cluster, because as we know, it may work on your machine, it's not going to work on the CI cluster. So without pushing upstream to GitHub or to your branch or anything, you just send a patch onto the CI cluster and you test everything there. Pretty simple and powerful. So speaking of CI infrastructure, we have in our master jobs 10 to 20 jobs that run in parallel. So we have all flavors of jobs. We need to build for the different targets, debugging or the public build, run all the unit tests, run the functional tests, run the linter. So that's a lot of different jobs to do, 10 to 20 to be precise. And we want to guarantee an SLA of 8 to 10 minutes. So we run everything in parallel onto our build machine that live in our data center. So for Android, we have 26, well, until last week, we had 26 Linux containers. We ramped up the capacity. We have about 100 builders right now. And for iOS, we have 50 Mac Mini / MacBook Pro combination. We're experimenting with the MacBook Pros right now. So we send all those jobs onto those builders in the data center, and everything runs in parallel. The way to manage this infrastructure, we use Chef to provision. I mean, it's pretty classic stuff. So we use Chef to provision all the iOS machines and Android machines to make sure all the build machines are identical as well. So let's talk about testing. We have different type of testing. The most basic one is the in-person testing. Like I said earlier, developers are supposed to test in the push queue. So when they push their code, install the app on the device, manually test it, they get some eyes on the app. All those builds are also installable by any other employees. So with dog food, or we call it nightly build, but really it's more than nightly. It's like 10 times a day. And then we have this concept of admin rotation. And the other idea is you're about to release a new feature. You're going to invite a few employees, like 5 to 10 people that wants to join. You get some food, you get some drinks, you get into a room, and then different devices, and you try to break that feature. You try to find as many bugs as you can in an hour. And that's a fun way to actually discover bugs and put people in touch that don't necessarily work together. But you're in the same room and you're having fun on a new feature, poking around at the app. Last but not least, we have our product quality team that runs the pre-release verification. So just before we submit the apps, they go through a rigorous testing process of the apps. So that's the last part of the testing, manual testing we do. I'm going to share a quick a tool that we are just starting to experiment with. Native apps generate events. Every click can generate an event, and the screen you go to can generate events. And the whole idea is we want to try to visualize those events and map them to the functionalities of the app. So we have access to real-time streaming of all the app's events. That's in real time. Like you click the phone, and within a few seconds, it's going to show up in a WebSocket. And this page is just monitoring all those different events for all the different devices. And when you receive an event, we have a green square that pops up. And the whole idea is during a pre-release verification, for instance, cover up the sol matrix in green, and that's going to give you an idea of what screen has been seen or where to orient your testing. What screen we need to spend more time on, which device and whatnot. So we're just poking around with it, but that's one tool that we use to assist the manual testing. So we also do testing, so unit testing and functional testing on simulators. For Android, we use Espresso for functional tests and Genymotion emulators. And for iOS, we use Kif. Like I said, we use Jenkins to build those jobs. We have one job by emulator or simulator target. And so we parallelize. So on every push, we're going to run 6 different test jobs, one on an iPhone, one on an iPad, different OS versions. And we use a build flow plugin to parallelize everything and then consolidate the results and report back. But as you may know, on simulators or emulators are very different devices, and that's when we use the device farm to do on-device testing. We use the Jenkins plugin API to schedule the tests, and then we use the API to aggregate the test results, and I will explain why and how. We schedule our test runs every 30 minutes. We'd like to get on push, as in whenever someone push upstream, we want to run the functional test. We're not there yet. For now, it's every 30 minutes, we just send the tests. And we also use those functional tests to collect on-device performance metrics, and I'm going to explain how later. For now, let's talk about the devices selection. A lot of devices, how do you pick it's called device pool in device farm lingo. We use Google Analytics for a lot of things, and so we added a custom dimension to get the specific devices on iOS, and we get the breakdown of top devices, top OS, and top resolution. You pick your combination, then you go back to the device farm. You can do it through the UI or using the API. We wrote a little wrapper to filter all the devices. So here I'm asking for the iOS phone devices, and have a list, and then I just handpick and match my criteria, what OS version, device, and whatnot. And then I can create a device pool. Again, we have a little wrapper tool, but you can do it on the UI. You specify which devices you want, and that's going to be your device pool where you can start testing on. So we run our tests on 4 different apps, where every time we try to use about 5 to 10 devices, and we run them every 30 minutes. That's a lot of test results. Way too many to go back and inspect manually every single one of them. Also, functional tests are flaky. Well, that's my opinion, but in my opinion, functional tests are flaky. You can be amazing at writing your tests, they can be flaky, and especially on physical devices. So we don't really pay attention to an absolute pass or fail results. It doesn't mean hold on everything, like something is broken, especially when we have all those test results. We prefer to monitor the trends, like how many, like, if has one test been failing repetitively for the past 5 runs? That's a strong signal that something is wrong, either with the test or one of the features is broken. Or did one test fail across all the devices at once? That's a strong signal. If one test fails once on the device, it could be flaky, it could be not. So the idea is really looking at the big picture. And again, to do that, we wrote a tool called the Jumbotron. And it's pretty much, again, a big grid showing you for the past n runs the number of successful runs over the total number of runs. The rows of the different tests that you run, the columns of the different devices that you run, and then you color with a success rate percentage your matrix. And that's a quick visual way to see where you stand. And then you can drill down, so you can click on that red cell, for instance, and get the detail of all the test runs. And if you click on a single one, you're redirected to the Device Farm console. You can go look at the log file, the performance file, the screenshots, and do all your analysis and debugging there. So I mentioned earlier that we do on-device performance monitoring as well, and the idea is pretty simple. Your functional tests are exercising a lot of screens and navigating in the app. And so we simply log to the device log the perf metrics that we're interested in, dump it in the device log, and then later use the API to retrieve the device logs, parse them, and once you find your key for the performance metrics, send that to Graphite. And then, boom, you have a performance graph based on actual physical device test runs, which is pretty valuable. So in this example, we're monitoring the app launch time, which is a pretty easy metric to get, and pretty important to monitor as well. So altogether, I would say that we started this journey about a year or 2 years ago. There's been a lot of changes along the way. When we started, we were using Calabash. Calabash is Ruby-based. And the issue we had was that developers were not really keen to write new Calabash tests. They prefer to work in the regular language that they use. So we switched to Espresso, which is Java, and Kif, which is Objective-C. And speaking of tests, originally the QA team were writing the tests, but the developers are writing the code and ultimately owning the code and changing the code and the tests. So we moved the ownership of the test from the QA team to the developers. Like I said, we have our own build machine in the data center. It's a pain, especially for iOS, but we make it work. When we started, we were also using our own devices into our device lab, and I was in charge of it, and pretty much I had to babysit the devices all the time. It was just a nightmare. So that's why now we use Device Farm. They manage the devices, they manage the upgrades, and they take care of all of that for us, and that's really a big time saver. So that's it for me.